So, picking up where we left off, differential equations in calculus 3. Yeah, it's whatever. So they're saying that they're saying that this they're saying that this is r prime essentially. So I got negative 3t, negative 7t, negative 3t, and eventually they want r. So I'm going from r prime to r. What do I do? Integrate. Exactly. Integral. So I'm gonna integrate this stuff essentially, and yeah, you can move the dt over. How Leibniz of you! I love it. It's not a math joke; it's a legitimate thing. You're right. Move the dt over, and then you can integrate both sides, and then it's legit, right? That's the power of Leibniz notation, but I'm using Newtonian as well. That's why I got a little prime symbol. So yeah, what's going to be my integral then here? 3t squared over 2? Okay. Uh-huh. Yes, exactly. Yep. Plus c vector. I don't know. And actually, this is important here because it's not a definite integral. We do need the plus c in there. So let me rewrite that a little bit more cleanly. That's c and then a vector symbol. It essentially means that I have 3 different numbers that are the plus c this, plus c that, plus c that. I'm just making it quick. But don't we have a c already? Didn't they give me something like that? Yeah, exactly. That's my c, and it's because it's r of 0. If it were r of 1, then I have to plug it in and solve and whatever. But because it's 0, just pop it in and you're good. So that's exactly it. I'm going to say, okay, well then I've got my original answer, which, forgive me for rewriting it all, plus 774. And I want to mush this all together. So yeah, you guessed it. It's just mushed together. There's nothing really new to talk about there. I'm going to flash the answer right quick. Yep, 774. There it is. Cool. So those are your 3 answers. We got them. Yay! Like, very, very simple, right? We integrate, plus those numbers, we're done. This is the kind of integration I like. Not that Cal 2 stuff. No way. No. No. Yeah. Yeah, no. Not that. Yeah, trig sub. Right there. That's enough. Mm-mm. I mean, they're fun when you're doing them. Not really, but it's fun later. Oh, yeah. And all those other classes. Because it's not just about this class. Um, is Yeah, exactly. Are we good here with this? Good. Rock and roll. Okay. So before we get to the projectiles, I mean, first off, I want to like go over what we're going to do. But then there's formulas for this, right? I would want to stick to the formulas as much as possible. So we find a formula, let's use it and be happy with it. So what is a projectile? My first thoughts is that we're probably starting at 0, 0, and then we're going to go. Pew. That's not what it sounds like, but let's go like that. Pew, and then it like. I don't know. That's not X. That's just the crosshairs or something. Yeah. And it goes boom. So yeah. Um, what we're wanting to do eventually is to find how high did it go. So this would be like the max height. We can find this thing called the range. The range is how far it went. Um, and then like how long was it in the air and all kinds of different things. So we're going to see that as we go. So it says it's fired at this much speed, at that much angle. How long, so they're looking for a t-value, will it take to get 21 kilometers downrange? Okay, now hold on for a second, hold on. 21 kilometers downrange. Is that meaning that this right here is at 21 for sure? It sounds like it, doesn't it? But can I assume it by just like looking at, oh yeah, 880 and 60 degrees, 21 kilometers, boom! Like there's no way I can know that. It could be exactly right. It could be somewhere around here, which I don't know. So, and we're wanting a t value, right? We're wanting to know t equals something. I don't know when that is. Um, so I'm not going to assume it's at the end. I can't just say, it's when it collides. I mean, I would love to say that, but it's not. So let's try to figure something out. I have my my position is going to be r cosine theta r sine theta, but that's not the entirety of it. There's more to it here. Now there's a formula for this, but what we really need is my initial x and then plus my velocity in the x direction times t, and then I have my y naught, my velocity in the y direction times t, and then it's actually a minus sign for gravity, isn't it? 1/2 gt squared. Still, though, I still don't like that. It's not clear enough. It's not plug it in enough for what I want. So let's try again. How do I get the velocity of my x and y components? Cosine and sine. That's what we were trying to do there, right? So we're actually using it, but only as a part. Yeah, exactly. So let's do initial velocity, not x, but initial velocity like total, like you said, times the cosine of theta, and then times t. Now this is where it gets a little confusing, and I like to put a dot in there to specify these are different things, okay? These are different things. What's going on is all of this is a single number. It's a single number. It's a decimal of some kind, okay? And then times t, right? How do I specify that? I just put a dot there. Or some other times what I do is put parentheses, which gets a little bit nasty, but it's up to you. I'm going to put a dot for right now, okay? I just want to make sure that you know that that is a number. We're going to get a number here, right here. And there's nothing else for x. Y naught, v naught, sine theta, again, times t, and then 1/2 gt squared. This is the more complete formula. And I know that we have it up above, but I wanted to reconstruct it from scratch so I can kind of understand where we're going, okay? With all of that, I think we can just start plugging things in, like as we see it. I'm going to ask, what's the initial position for all this stuff? It's assumed. It's assumed 0, 0, because we didn't have anything else. What's my initial velocity? Yep, 880. And my angle was? Perfect, perfect. Again, all that's going to be a number here in a second. Assuming a 0, 880 sine of 60 times the t. Now, last time, like yesterday, we had gravity. I had mentioned it was like the 32 or whatever. But what is gravity in this case? There you go. You know what? We're in a math class, so let's do that. Oh, okay, that's good. Yeah, I know physics goes 1 because it's fine, right? Physics is fine. It'll be fine. Close enough. So that's a lot of stuff going on, but what I really want from that is numbers, right? So let me get some Desmos up here. Give me a second. Sorry about that. And rip. Okay, so I'm basically using the scientific calculator to get some stuff out of this. Notice that it's in degree mode, so that's kind of nice. Okay, so I've got 0 plus whatever, so I got 440 t, which is kind of weird how easy that was. But then again, it's not really weird because it's 60 degrees, right? Cosine of 60 is perfect. All right. The next one obviously will be a little bit more than that. So I got 762.10235. They're okay with decimals, so I'm just going to go out a couple. 5. And then 1/2 of 9.8 is the 4.905. T squared. Oh, I forgot something. T. Forgot a T there. Man, I do that all the time. Okay. So we have a position, right? This is my position at any time. What I want from that is to now know what time, so that I can get down to what was it, 21 kilometers? 21 kilometers. So I just like say equals 21, because we're in meters, aren't we? So what is this actually going to be in meters land? 2,000. So is it like this? Meters? Because K means 1,000. So you put like and it's all good. Okay, so downrange, let's talk about downrange right quick, okay? So this is something, and we're gonna plug something in, and we solve for T, right? That's kind of what we're looking at now. But when it says range, normally I think Y values, but that's not the case with projectiles, right? Apparently that's X. So I think they're saying like this is like X equals, I think. Like how far away from you? Because everything is going to come back down. Right. Yes. So yeah, I think they're saying that X is equal to 21,000, and then solve for T. So I feel like we did way too much work, because this is my X, this is my Y. They're just saying that X is equal to 21,000 is just this guy here, and they want to solve for T. This is my equation, solve for T. What do I do? Oh. What? 4905? Yes. But ultimately, that didn't even matter, apparently. So let's just divide those. 47.7272. Of course, they're wanting decimals, right? They said 2 decimals, so 4773. What would that be? What units? Seconds, yeah. They said seconds up there, and we didn't ever need to change that one. Everything was in seconds to begin with. I'm going to flash the results. There we go. We got it. So we way overdid it. Like, we did not need any of that Y. But that's fine. And then I go back and analyze the problem. It's not like we can just say, oh, I know where we're going with this. I mean, maybe y'all do. I don't know. I like to set it up and just kind of work backwards, I guess. Cool. So in the end, it was literally just taking a number, you cut it in half, and then you divide, and you're done. Wow. That's kind of silly. True that. You know, I'm going to do that right quick just so that I feel like better closure. I want closure to this problem. So then times the 47.723 minus 4.095 times 47.73 squared. And yeah, that's the sway in the air somewhere. I mean, just like verified, I did the formula, right? So yeah, it's somewhere high in the air. So it was not when it's colliding. It's just somewhere along the way. Which is, so there's a formula for that. Yeah, let me scroll this to the side here. So if you go back up to the we do right there. So like we can just plug it right in. Boom, done. Super fast. So I would recommend that if they're just saying find the range, which they will here in just a second. So yeah, let's keep going. Are y'all good with this? We only used X. This is kind of lame, but whatever. And so you can see this one. Oh yeah,
I was just saying, I don't know if it holds anybody thinks, but the x component of velocity is never affected by gravity.
correct.
It says it negates, or it usually negates air resistance, so that x component is going to stay the same throughout. So
Yes.
if you ever need to find the position on the ground, like that question, you just take the x component of the velocity, multiply it whatever time.
Yeah.
That's how I.
Exactly. Very simple math, right? As long as you know where it is, x-wise. Yes, 100% true. Keep it easy. This one is easy because we have formulas. Now, if we had no formulas and I had to create them, of course, that would take a lot longer. But here it's not too bad. So projectiles fire from initial speed of this, angle of that, go. So when will it strike? So it's again, I'm gonna like redraw it. It's doing this, right? So they're saying t equals what down here, right? It's also saying how far away. So they're also going to ask basically x equals what. So let's go and do that. I'm going to go and like find some formulas that do t and x. So range, there it is. That's my x value essentially, right? So I have that formula. And then flight time right there. And they look really similar, don't they? They look really similar. Okay, so 2v naught sine alpha a. Okay, so hold on. 2v naught sine alpha, I guess, or theta, all divided by g. Yes, that's for the I'm going to use theta. I don't want alpha. And then my range is v naught sine of 2 theta divided by g. Oh, thank you. Sine 2 theta divided by g? Yes. I'm going to verify. Is that okay? No. Okay, you're right. Yep, very good, very good. So, like, those are my two formulas I need for the first things. And I am literally plugging them in. Do I say literally too much? Literally, yes. Oh, thanks. Because we're talking meters and seconds and stuff, that G is 9.8. Little reminders like that. Okay, so yeah, I'm gonna just plug them in right quick and get us some stuff. Clear. Let me scroll this a little bit and there. I like zoom in a tiny bit. I like that better. All right. 2 times 600 times the sine of 60 divided by 9.8. 106.04. Y'all sing when you're doing math? Me neither. Me neither. The funny thing is when I'm doing prep work for mainly for like non-recorded streams like this, like the ones that I pre-make, I have to do the math beforehand so I know what I'm doing, and I listen to history lectures when I do that. It's very soothing having a history lecture in your ears and you're doing math. It's beautiful. Let me see if those are the answers. Yay, 31, 8, 12. Yeah. Well, okay. So obviously my my other answer is a little bit off, but I really hope, that they would accept this in a range. So again, notice that it's off by 1. If it doesn't work because of like an off by 1 thing, you tell me. Send it in. Do the ask my instructor. That way I can have a list of things to yell at them about. You know what I mean? Because yes, I am. This is a pilot. We should be angry at them. Angry that they made it free for us to do all this. So angry. Okay, so it's cool we had formulas for that, right? I love it. I love formulas. They're great. Are we cool with the formulas? Good. Copy paste, right? Okay. Um, how high overhead will the projectile be when it's 5 kilometers downrange? So we know that the full distance is 31,000, basically. So 5 is like right around here, let's say. That's 5,000. So they're wanting to know how high. So we want the y value. And what's the greatest height? That's going to be the max up here. Which I think there's a formula for that too. We'll get to that. So how can I find the y value here? Well, we need a formula for the y values, right? Here we go again. Y naught plus v naught sine theta times t minus 1/2 gt squared. What's my initial y? Sure. Initial velocity? Cool, cool. Angle of? Sweet. And then my g was? Thank you. Okay. Well, this will tell me how high. Cool. 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 Question. What's my t value? Is it 5,000? Oh. So you mean I have to keep doing more math? What is 5,000? X. It's X, exactly. So, okay, hold on for a sec. I got this cool Y and it's all ready. Here we go. That's my answer. But I need a t value. Oh. So let's go and do the X. X naught, V naught cosine theta times t, and that's all there is for this one. 0, 600 cosine. Oh, we already know the theta. 60. Times t. Hi. Yes, please get coffee. Yeah, love it, man. Thank you. And I know that my x is 5,000. So now I just solve for t. So what do I do with this, whatever number that's going to be? Divide. Yep, you got it. This is not the answer, but it is something I need. So let me kind of scroll this to the side here. So 5,000 divided by 600 cosine of 60, 16.667 seconds. Good so far? What do I do with that t again? There it is. Plug that back in, and then we should be able to get our final answer finally. Finally. Ah, Chad, why you do that, Chad? Using variables. Boom. You see the answer? 7299.26. See you later. They're probably going to round it up. Like, you didn't round right. Oh no, look, I did get it right. Cool. Okay. Yeah, what? 600. Oh, that's just the 600 up here. So yeah, V naught theta. You're good. Yeah. Ask all the questions. I'm perfectly happy sitting and talking about this stuff. I need y'all to do one. That's right. I've been doing all the math today. Y'all need to do a math problem. Yeah, well, it's not raining anymore. Thanks. Yeah, thanks. Yeah. Are y'all okay with the idea? Okay, because you like looking at me, bro.
Well, you were talking to me.
Hi. Good. So, we I go for my y. That's what I want. Oh wait, I need a t. So let's go to x, get the t, and plug it back in. I don't think ahead very well. Let's just say that I don't think ahead. I just I don't know what to do. So I just start trying stuff, and that's often what happens. The last one's just a formula, isn't it? It says the greatest height. I'm sure there's a formula for that. Yeah, right there. Look, boom, we got it. So v naught sine theta all squared, and then divided by 2g. So v naught sine of 2 theta all squared. No. Is it 2 theta?
Which one?
The height, the max height?
Max height, it's a V naught sine angle.
I was going too zealous. Everything gets a 2 theta. Okay. Yes. Oh, yeah. Let me blow it back up. There you go. So 600 sine of the 60. Make that 6 look a little bit more 6y. Okay. Y'all are like, yeah, it's Cal 3. Okay, you can't make stupid jokes anymore.
I don't know why you're sitting there making stupid jokes.
So I plug it into the formula. Let's do that. I'm gonna go and let's plug it in, see what we get. I really like when there's formulas. We should definitely use them as much as possible. Okay, 13775.51. Let's flash the answer. Yep, we're good. Okay, awesome. Again, rounding the. Even in algebra classes, they have a plus minus leniency on this kind of stuff. So I'm not really worried about it, but you never know. It is my math lab. So okay. Cool. That was a lot. But 3 out of 4 was formulas. So that's not too bad, right? Yeah, I mean, this is pre-cal problems essentially.
I was actually about to say that. Like, I felt like we dealt with some of this.
Oh, yeah.
It's a little less complicated.
Well,
In certain formulaic aspects, I guess.
yeah, I mean, they're wanting to get the emphasis for a vector rather than just formulas. Happily, they gave us formulas, so we can kind of circumvent that a little bit. But, yeah, it's a pre-cal problem. Same thing with this one, and then another one, and then we're done. So 2 more projectiles. Lots of projectile stuff, so that's okay. A spring gun at ground level fires a golf ball at this much angle. It lands this much away. What's the initial speed? Okay, so I always like to draw a picture, and it's going to do this, and it does that. This angle, we know, this angle is at 45 degrees. What's special about 45 degrees? Give me some English. Yes. Why would you want to use 45, not just for golf balls, but other applications? Why not 30? Why not 60? Why is 45 special? There it is. Exactly right. Maximizes your distance and height accordingly. I mean, if you're looking for both, you got both. Yes. Yes. So you could go higher and it bloop, or you can go lower and it bloop. But it maximizes the distance and still gets a good height. So yeah, lots of good stuff there. And that is another calculus problem. So back in the day, we had a calculus problem where you're on the side of a mountain, and then you have to hit something down there in the valley. I remember doing that in calculus with my professor. Anyways, so that's what we got, and it says we got 12 meters for my range, and it says what's my initial speed. So how fast did it come out of that spring gun? Oh, I like that. Let's do that. Yeah, if there's a formula. So range was
Yeah, it was R equals VO squared sine 2 theta over g.
thank you very much. That's perfect. We know the range is 12. We don't know V naught. We'll get to that later. We know that the angle was 45. And because we're talking meters, then it's 9.8 again. And basically all of this turns into a big number, right? I'm going to clear. What? Rearrange? I'm playing with you, of course. So yeah, 12 is equal to V naught squared times, and basically it's this decimal. But there's so many easier ways to do this. 2 times 45 is 90. Sine of 90 is 1. So you can just get rid of it, divide, multiply to 9.8. Whatever you want to do. I'm just trying to show you, like, in case it's a different angle. Then you could do this. Square root both sides. Hey, Chad, whenever you square root both sides, you have to. Not in this class. Well, not right now. Well, I guess it wouldn't matter that much. And well, the spring is negative velocity, whenever the golf ball's the other way. Yep. So this should be meters per second. 10.8. Let me just real quick flash the answer. 10.8. We got it. Okay, cool. But obviously, there's a problem here. I wrote too big. So I got to figure out what they're wanting on part B. But yeah, I think that using the range formula was a really good idea. I didn't first think of that. I was going to use X and go get the formula back out and stuff. But having the formula already there, that made it super easy. So thank you. That was a great idea. Exactly. Exactly. Yeah, so much easier. So thank you. Good call there. So firing two angles? Here, let me just read the rest of it here. For the same initial speed, find two firing angles where the range is 5. Oh, kind of similar to what we were talking about. So this is pretty cool. I'm going to use a different color. Yeah, we're finding the 2 thetas. So what are they wanting is now it's not 12, it's 5. And they say we can pop fly or we can just kind of ground ball it. And there's 2 different angles that we can get for that. Okay. I don't think. No, well, hold on. Hasn't the range now become 5?
Yes. The range has become 5. So we have the same.
And we know the initial velocity.
Yes. When this gets theta, our only missing piece is theta.
So we can use the same formula again. That's pretty nifty. So yeah, I like that. I'm going to use the red, of course, now. So we got 5. That doesn't look like a very good 5. We got 5 is equal to, my initial velocity is the 10.844 squared sine of 2 theta, all divided by 9.8. Again, all of these are numbers here, and I want to, like, move them over. I don't know how, like, to me, I don't go and solve this. I just start tossing things to the other side. So yeah, if y'all are cool with that, I'm cool with that. I say times the 9.8 divided by this 10 whatever stuff. I use a calculator at the very end if I have to, but that way I've got my sine nice and clean, and then I can start doing trig stuff, I guess, here in a second. Sounds good. I'll get there in just a second, I guess. You're way ahead of me. It is straightforward. I think mainly because we have the formulas helping us, which is very good. I'm not going to downplay that. It would take a lot more time because you'd have to solve for t and take t and plug it back in and da 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 da. And yeah, I mean this is a classic problem here. I just never thought of using the range thing, so that's pretty cool. All right, so this is what we got, and I need to solve for theta basically. And so this is all Desmos at this point. There's no way to do it by hand. Like you said, arc sine of the 416693 is going to give me, and I'm in degree mode, right? But it's not just that, because that's 2 theta. So what do I do with this thing? The whole thing divided by 2. The whole thing divided by 2. Now, before I keep going, I don't even want to write anything down. I want to see, am I in the right direction? So if you go there, 12.3 is one of the answers. So that's very nice. Okay. I want to write that down here. So, okay, from here, I did the arc sine of the 416693, and then I divided it by 2, and I got theta was 12.3 degrees. So that's sweet. And let's time out big time right now, because I mean, there's other ways to solve. We can say, well, there's other, y'all know from pre-cal, y'all know that because there's a 2 theta, we're going to have to solve more answers, and I can't remember how to do that. I don't really care. So, but there's indicating that there's 2 sets of answers for us, right? We're going to do that, kind of, but there's an easier way. Are y'all okay with the 12? Arc sine divided by 2, right? Because that was 2 in there. So if you go back and look at the answer again, there's a relationship between these 2. You see the difference? Literally. 90. Yep. And so let's conceptualize for a minute here. I'm going to do the 45 again. So 45 will give me this. But let's say I did like a 30, or I'm sorry, that's a 60, and then a 30. Like in a way here, opposing angles are giving me the same answers, but why I only have this one way out here, it's like 45, 45 in a way, right? We've got 45, and then what's 90 minus 45 is 45. So it's like the 2 angles are the same number. So it's as one gets bigger, one gets smaller. And kind of think of it also very silly here. What if you had 0 angle and you shoot it right down to the ground? Boom. Or you can go at 90 and you go bloop and it goes whoo and it comes right back down and hits you. Right? So 0 and 90 are also going to work together. So they're complementary. Is that complement or supplement? Oh, who cares? Geometry? So yeah, I'm just going to do 90 minus that value to get, was it 77.7? That's okay, cool. And then there we go. That's how they got the 2 answers. Could we go and try to solve that with trig? Sure. But this is just one of those things from like projectiles. It's one of those properties, I guess you can say. There it is. I like that. That's exactly right. The sine of one is the cosine of the other. Yes, that's right. Very good. Cool. All right. Any questions? Questions? Okay. Cool. Another one. This is the last one finally. Lots and lots of projectile, which is important. I mean, it's a good thing. So shot put is throwing. Ooh, look at those things. Ah, they're not metric. Oops. And yeah, look, we got feet and inches. Look at how wonderful. Let's go to Mars with these kind of dimensions, right? Assuming we got 40-degree angle to the horizontal, 6 feet above the ground, what was the initial speed? Oh, I know, right? Just just to make it funny. Yeah. Um, I don't know if this is. Yeah, I don't think it does. Exactly right. You drop a cannonball or a feather from the Tower of Pisa, and well, the feather gets down there eventually. But but the point was in a vacuum, and the point was that they dropped the same. Yeah, isn't that the story though? It was a cannonball and a feather. I know it's the Tower of Pisa because that's why it's leaning. No, I'm just joking. So it's like okay. Um, so yeah, I don't think this matters. And this guy here, oh, he threw it. That's a range. Is that a range? But we have to keep in mind that it was 6 feet above, and I don't know. I think that's going to throw off our range formula. So we're actually starting here at 6, and then it does this, and we got in the end 68 feet 10 inches. And this is 6 foot. Okay, and then my initial angle is 40 degrees. Okay, and then I just need, what's my initial velocity? I do think that having it not at 0 is going to throw that formula off, and I do not want to use it. I don't want to even attempt it because it would just waste our time. So I need to recreate my formula from scratch, and that's okay. So I'm going to do my R is both X and Y, just like we always do there. What's my initial X? 0 still. V naught cosine 40, comma. And my initial Y is 6. V naught. Oh, there's a T in there. Gosh, man. I forget these things. There's a T in there. Sine of 40, then a T. Then again, 1/2. Uh-oh, what's my gravity this time? 32. Oh, they told me 32. Look at that. Okay. We didn't have to know that. How many feet are in a mile? Quick! Yes. For a long time, I thought it was 5260. That was incorrect. Incorrect. Keep getting problems wrong. Yes, 5280. Okay. So I need to do something with this. I know that my range here is 68 feet and 10 inches. I mean, that's even gross looking. You know what I mean? Like, what am I supposed to do with this? I could then from here solve for t, right? And then with my t value, well, yeah, yes. Well, that's another way to take it. Yeah, I like that. Let's do that. I'm going to do that with you. Yes. So then basically I'm going to take that and plug it in here into these t's, and then I could solve for V naught. That's my goal, okay? Like I don't know what V naught is, but I'm going to plug in like some kind of a formula, kind of. Now you're right though. The reason why I could do that is over here y equals 0. So essentially I'm saying blah, 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 blah equals 0 in the end, right? And that's my equation that I could solve. I like that. That was excellent. Okay, so how do I convert this into something better? You use a calculator. So it's 68 plus 10 over 12, essentially. And so I got, huh? They have feet in the end, and I'm going to be scared. Yeah. Well, you can. I don't know how. All right. Gosh, don't yell at me. Well, true. I'm happy with decimal points. So, I don't know what cosine 40 is. Let's see that. And in fact, because got all this stuff here, 76604 V naught and then a T. Again, I want to solve for T so I can plug that in over on the other side. So I'm going to take all this stuff and divide it over here. Therefore, I get T is equal to 68.8333 divided by this decimal stuff. And I'm going to simplify that down here in just a second. There's a V naught in the denominator. Does that scare you? It scares me. I'm not saying that it's wrong. I'm just saying I don't like that. It's like, meh. 89.856, and then divided by V naught. So that's kind of a weird thing. I'm going to switch colors now. So I'm going to use this and plug it in here and here. Here we go. I mean, I don't know of a better way besides just toss it in there. Nope, not 6 equals. No. 6 plus V naught. Hold on. Sine of 40. I know that they're decimals, but that's how we're going to have to get this done. 89.856 all over V naught. I'm going to erase this stuff. We don't need it anymore. And then minus 16 times this 89 whatever stuff, V naught all squared. And that whole thing should equal 0. We're gonna do that, of course. Erase that other stuff over there. All right, tell me something good. What's a good thing that I can do with this? Whew. Thank goodness, because man, that was not a happy equation to solve, right? Now I only have the 1 V naught. Even though it's denominator, we only got the 1, which is nice. Let me mush all these together and start simplifying my numbers there. So 6 plus all this other stuff here, 42787 times 89.856. Yes. So I got 0 equals this stuff here, 26. Math up there. Oh yeah, it was 6. And I'm squaring that value. Oh my. 1.8. And then that was my numbers, and I'm still dividing by V naught squared over here, which is strange. You know what I've noticed just recently, like just now? I haven't messed up in a while. That's not good. I haven't gotten something wrong recently. You remember, I have to get something wrong every day, at least once. Now's the time, guys. What would you do at this point? That's probably better. Yeah, I like that. You're right. That's a better idea. I was thinking the 63, but the negative would be better. So then, and then you said multiply? Yeah, by the V naught squared and then divided by the 63. Excellent. Excellent. Yeah, so move this one over here and move that one down here. Get a little bit more room. We got room on the side here. And so then I got 129,185 bada 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 divided by the 63 bada 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 is equal to V naught squared. Get a number for that. 9185.611. Lots of decimals, lots of decimals, lots of decimals. Would you have avoided all those decimals?
Some of them maybe. One of these be as precise.
How do I get rid of the square?
Square root.
Square root both sides. And again, in this class, you don't need no plus and minus. every rule you learn, just ignore now. Okay. 45.013. This is a huge problem here. This was huge. Meters. No.
Yeah, there's the
Freedom units?
Yeah.
That's so funny. And that's a funny way to think about it. Let's go flash the answer. And 45.0. Yep, that'll work. Cool. Oh my goodness, that was a lot. Lots of decimals. Right. So big picture, what did I do? I had my value for x. I solve for t. I take t and plug it in over here and solve for v naught. It kind of is almost back to like the matrix stuff back in algebra chapter. Not it wasn't matrices. It was before that. The system of equations stuff, right? Chapter 8. Way more decimals, but still not too bad. We got a couple more minutes. But any questions on that? No? Okay. It took a long time, but the projection of the problem was right. Okay, cool. Arc length. Have you already seen the formula?
Yes. It looks a lot like what we had to do last semester.
Yeah. Well, it should. Go ahead. So yeah, in Cal 2, your arc length formula, I think, and I'm trying to remember it all, it looked more like 1 plus f prime, yes, I remember now, f prime all squared dx. This is the exact same formula. Copy paste, okay? Now, we have to add different dimensions, but this guy right here, your derivative of z is 1, and so that's how they got that 1 right there. I don't know why all this is coming up all of a sudden. But yeah, gosh, leave me alone. So this guy, that's your 1. But again, that was because it's 3 dimensions. Back in 2-dimension land, that's your 1. So like, I would say, like, what's the derivative of y in terms of y? What's dy over dy? 1, because they canceled. I mean, like, Leibniz, woohoo! So yeah, it is the same as Cal 2. It is. It's just now we're adding more dimensions and the ability to go further. Cool? So like technically without actually saying it, it was x prime squared plus y prime squared dx. It's just that because it's dx, this guy turns into a 1. 1 squared is 1. Yep. Very good, very good. So yeah, it is the same formula, which is nice. Yay, we've done this before. So arc length. And so we basically should know a little bit about arc length. We just have an arc, and we're going to say how long it is, and we're good to go. Now, this thing here is new, and this thing here is sad face. Okay? And if we go to the next section, which is even worse, it's like triple sad face. I'm going to scroll ahead. We're going to get to all this later. Give me a minute. And this guy here, see, there's T again, but this guy right here is like super sad face, okay? And then all this here is, again, super sad face. I like this one, and I think that's it. Do they have B in this section? I can't remember. B is like triple sad face. We're going to have to learn it, and that's okay. We're going to like start easy. So this is unit tangent vector, and it's basically just the tangent, the velocity vector, essentially. And if you look at it, look, it's the velocity vector. And you're just dividing by the magnitude to make it a unit. Doesn't seem too bad. I mean, all you're doing here is just saying, I want my velocity and make it a unit vector. Very simple. until this has variables, and that's the problem. So then you're going to get square root of blah 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 t squared blah 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 blah, and then you're going to have to go further, and it just gets worse and worse. But we get there one step at a time. So yeah, let's do a problem. We got time. We got 3 minutes. Let's just look at it. So they say find t. Now I want to do this one so that you're not like too freaked out by it, because it's really not that bad. Let's find the derivative. So what's the derivative of this guy? -4 sine. Okay. And this guy right here? And this guy here? Square root 2. This one's going to end up so much nicer. This is so beautiful compared to, well, okay. It's just so beautiful. What I need now is the magnitude of v. We already have v, so I just wanted the magnitude, which is very simple on how to do this. You take each one of these and you square it, and then you do the square root deal, right? Piece of cake. So far, so good? Well, then my t is just the v divided by the magnitude of v. I mean, you're like looking at the answer, essentially. Right here, look, division. We're done, and I'm super serious. Go ahead. Yes, actually, that's true. Phew. So that's going to be a chapter 16 kind of thing there. You're right. This right here is that thing, that arc length, and if you integrate that, you go back to the position that you've traveled over time, which is arc length. Very good. Man, I love that analysis. That was so cool. Thank you for that. Yeah, it is a pattern. Very good, very good. But there's a different pattern here that makes this one easy. Notice that we got sine squared. Hi, man. We got sine squared and cosine squared. Yes. And in specific, because we have the same 4 in the front. So what this means is that we got 4 squared is 16 and 4 squared is 16. So this whole thing here turns into a 16 because, again, sine and cosine squared make a 1, and they kind of mush together. And then right here, square and square root. So we got square root 18 now. And so I'm taking whatever I had, divided by square root 18, and we're done. And you do not need to simplify, obviously. I'm going to flash the answer here in just a second. Cosine of t. And then square root of 2 divided by square root 18, I guess. I don't know. So let's check that out. Did we do it? I know, right? So 18 is 9 and 2. So we pull a 3 out, and then the 2's would cancel. 3 into the top, leave a 3 in the bottom. So 2 square root of 3 over 3. Oh, well, okay, I was close. Yeah. But it does seem to simplify down to what we're looking for. We don't have time for this one, but you can see it's really honestly not that bad yet. So okay. See y'all later. Thank you guys. It's always fun.